Welcome to the second lecture of the course Engineering Chemistry. Today we will study about the terminologies associated with the electrochemistry. Learning outcomes from this lecture. At the end of the lecture, students will be able to define electrochemistry and electrochemical reactions. You will be able to define redox reaction. You will be able to identify oxidation, redox reaction, reduction. You will be able to discuss the terms such as anode, cathode, and electrolyte. Now we know that electrochemistry is a 200-year-old science, and we will define electrochemistry like it is a branch of chemistry that studies the relationship between electricity and chemical reaction. Electricity and chemical reaction relationship, those kind of reactions are known as electrochemical reaction. So definition of electrochemical reaction is if a chemical reaction is caused by electric current or electric current is produced due to a chemical reaction, then the reactions are known as electrochemical reaction. So two types of electrochemical reaction. If a chemical reaction is caused by electric current or electric current is produced due to a chemical reaction, we can call those reactions as electrochemical reaction. For example, electricity is produced in a battery due to the chemical reaction. So here chemical reaction happened and due to that electricity produced. So it is an electrochemical reaction. Similarly, if you are doing electrolysis of water to split water into hydrogen and oxygen, here you supplied electric current and chemical reaction occurred as the result of the supply of electric current. This reaction is also an electrochemical reaction. So in the first example, electricity is produced by a chemical reaction, and in the second reaction, a chemical reaction occurred due to the supply of electricity. Both are electrochemical reactions. In your PUC, you studied about voltaic cell and electrolytic cell. The reactions happens inside the voltaic cell and electrolytic cell. Both are electrochemical reactions. In voltaic cells such as galvanic cell, electricity is produced due to the chemical reactions inside the cells. In electrolytic cells, electricity is given to the cell to make a chemical reaction to occur. So in this unit, we will mainly concentrate on the first type of electrochemical reaction, where electrochemical reactions where electricity is produced due to chemical reaction. We will concentrate mainly on this electrochemical reaction. In oxidation, release of electron occurs. For example, a zinc atom releases 2 electrons and becomes zinc ions. So here release of electrons occurs. So this reaction we can call it as an oxidation reaction. In reduction, acceptance of electrons occurs. For example, an ion, copper ion, it accepts 2 electrons and form copper atoms. So here acceptance of electrons. Acceptance of electrons are known as reductions. So now we studied about the definition of oxidation and reduction. In a redox reaction, both oxidation and reduction occurs simultaneously. That means in redox reaction, both release and acceptance of electrons occur. Electrochemical reactions are redox reactions. Then how to check whether the given reaction is a redox reaction or not? If both oxidation and reduction occurs simultaneously, then the reaction is a redox reaction. If oxidation is involved, then at least one chemical species will release electrons and gets a higher oxidation state. So in oxidation state of the species will increase. If reduction is involved, then at least one chemical species will accept electrons and gets a lower oxidation state. So oxidation state of one species decreases in reduction. If we can write the oxidation states of the atom in a chemical equation, then we can find whether oxidation and reduction occurred simultaneously and check whether the reaction is a redox reaction or not. Reaction or not. For example, I'm giving you one equation. Consider this equation. Hydrogen reacts with oxygen, forms water. How to check whether this reaction is a redox reaction or not? Very simple. First we have to find the oxidation states of all the atoms present in this reaction. For example, hydrogen in its elemental form, so its oxidation state is 0. Oxygen, oxidation state is 0. In compound, water is a compound, and in compound oxygen, oxidation state is -2. Hydrogen oxidation state is +1. Now you see, for hydrogen, what happens? Oxidation state increased. Oxidation state increases. If oxidation state increases for a species, then we can call that species undergoes oxidation. Similarly, here you can see oxygen oxidation state is decreased. So oxidation state decreases. So here a reduction in oxidation state happens. So we call that reaction as reduction. So in this reaction, oxidation also happened, reduction also happened. So this is a redox reaction. Second example, we will check whether this reaction is a redox reaction or not. Here, it is a famous displacement reaction. Zinc reacts with the copper sulfate forms zinc sulfate and copper. How to check whether it is a redox reaction or not? Zinc in elemental form, oxidation state 0, copper +2, oxygen -2, sulfur +6. You have studied how to find oxidation state of compounds. -2, +2, +6 and 0. Here, oxidation state of zinc increases. So this reaction is oxidation. Copper in copper sulfate has an oxidation state of +2. Now it reduced it to 0. So a decrease in oxidation state happened. So this reaction is reduction. So in this reaction, both oxidation and reduction occurs. So we call this reaction as a redox reaction. How to check whether the given reaction is redox reaction or not? Another example, third example. Hydrochloric acid reacts with the sodium hydroxide and forms sodium chloride and water. A very famous neutralization reaction. We will check whether this reaction is a redox reaction or not. We can write the oxidation state of all the atoms in this reaction. Chlorine in compound form -1, hydrogen +1, hydrogen +1, sodium alkali metal +1, oxygen -2, sodium chloride -1, sodium +1, water, oxygen -2, hydrogen +1. We are going to check whether any oxidation or reduction happens. Is there any species which got a higher oxidation state in this reaction? Hydrogen +1, in right side also, hydrogen +1, there is no change in the oxidation state of hydrogen. Chlorine atom, Cl-, there is no change in the oxidation state of chlorine. Sodium, no change. Oxygen, no change. So there is no change in the oxidation state of atoms which took part in these chemical reactions. So this is not a redox reaction because here there is no oxidation, here there is no reduction. So this reaction is not a redox reaction. So in this neutralization reaction, no atoms changed its oxidation state when they took part in chemical reactions. So this neutralization reaction is not a redox reaction. How to find the oxidation state of atoms? You have studied this in your school, but if you forgot, then I will give you some hints to remember all the concepts that you studied in your school. All atoms in their elemental form has an oxidation state of 0. So if an atom stays alone, then its oxidation state will be 0. If you add the oxidation states of all the atoms in a compound, gives a sum of 0. Except in hydrides like sodium hydride and potassium hydride, hydrogen generally shows an oxidation state of +1 in its compound. Except in peroxides and superoxide, generally oxygen shows an oxidation state of -2 in its compounds. Alkali metals like lithium, sodium, potassium, rubidium, they show oxidation state of +1 in most of their compounds. Alkaline metals such as calcium, barium, they generally shows an oxidation state of +2 in their compounds. Halogens such as fluorine, chlorine, bromine, iodine, they generally shows an oxidation state of -1. Transition metals, they shows different oxidation state. Zinc, copper, in most of the compounds, their oxidation state is +2. Silver also, its oxidation state is, most of the compounds, it will be +1. For aluminium, it is +3. In majority of the compounds. There are exceptions also. Now we will study how to find the oxidation state of atoms in a compound. Two examples we will study. First one, potassium dichromate. We know that potassium is an alkali metal, so it has an oxidation state of +1. Oxygen is having an oxidation state of -2, but we do not know what is the oxidation state of chromium. As per the second rule that I discussed in the previous slide, if I add all the oxidation states of all the atoms, then the value should be 0. The sum should be 0. We will do that. 2 potassium atoms are there. Each potassium atom has an oxidation state of +1. So 2 into +1 plus 2 chromium atoms. And we do not know what is the oxidation state of chromium. So that is X plus 7 oxygen atom. Each oxygen atom has an oxidation state of -2. If we add all these things, we should get the value as 0, sum as 0. So 2 plus 2x minus 14 equal to 0. 2x minus 12 equal to 0. 2x equal to 12. X equal to 12 by 2 plus 6. So here oxidation state of chromium is +6. So we can write oxidation state of all the atoms in potassium dichromate K2 +1, Cr2 +6, O7 -2. If you want to check whether you have done it in the right way, you just add all the oxidation states of all the atoms, then you should get the value as 0. Second example, potassium permanganate, a famous oxidizing agent. How to find oxidation state of all the atoms? Potassium alkali metal +1, oxygen -2, manganese we don't know because it is a transition metal. Once we add all the oxidation states of all the atoms in this compound, we should get the value as 0. So potassium, 1 potassium atom, so 1 into +1. 1 manganese, we do not know what is the oxidation state of manganese, we consider it as X. 4 oxygen atom, 4 into -2, total 0. 1 plus X minus 8 equal to 0. X minus 7 equal to 0. X equal to +7. So now I can write all oxidation state of all the atoms. K plus 1, manganese plus 7, oxygen minus 2. We will study about what is an oxidizing agent and reducing agent. In a chemical reaction, especially in a redox reaction, the chemical species which helps other species to get oxidation is known as oxidizing agent. So oxidizing agent will help other species to get oxidation. Don't be confused. Oxidizing agent won't undergo oxidation. Oxidizing agent helps other species to get oxidation. Similarly, the chemical species which helps other species to get reduction is known as reducing agent. So a reducing agent which will help the other chemical species to undergo reduction. We will take an example. Very famous displacement reaction. We are writing oxidation states. Zinc undergoes oxidation because it changed its oxidation state from 0 to plus 2. Copper in copper sulfate undergoes reduction because its oxidation state decreased from plus 2 to 0. So in this reaction, who undergoes oxidation? Zinc undergoes oxidation with the help of copper sulfate. So when zinc reacted with copper sulfate, zinc got oxidized. So who helped zinc to get oxidation? Copper sulfate. So copper sulfate is oxidizing agent. Similarly, who undergoes reduction? The copper sulfate to copper. That conversion is a reduction reaction. Copper sulfate undergoes reduction when it reacted with zinc. So zinc helped copper sulfate to undergo reduction. So zinc is reducing agent. In this reaction, copper reacted with silver nitrate, formed copper nitrate and silver. This is also a displacement reaction. So here, what happens to the copper atom? Copper atom got an increase in oxidation state. That's why copper undergoes oxidation. In silver nitrate, the oxidation state of silver was plus 1 and it converted to 0. So there is a reduction in oxidation state of silver happened. So silver nitrate undergoes reduction. So here, who undergoes oxidation? Copper undergoes oxidation with the help of silver nitrate. So silver nitrate acts as oxidizing agent. Similarly, silver nitrate undergoes reduction with the help of copper. So copper here acts as the reducing agent. In a voltaic cell, electrochemical reaction occurs. And electrochemical reactions are redox reaction. So in a redox reaction, both oxidation and reduction occur. Now, in a voltaic cell, the electrode at which oxidation occurs is known as anode. In a voltaic cell, the electrode at which reduction occurs is called cathode. Now, how to check or find which electrode is anode and cathode? That we will study in the next class.